Yes.
Novel 3D printing for surgical wet lab practice and innovative instrument design by Dr. John Davis Akkara and Dr. Anju Kuriakos.
The authors have no financial interest in this presentation. We are releasing the designs open source and free on Thingiverse and National Institute of Health 3D Print Exchange.
It is difficult to be prepared for complex eye surgeries using CTR, CTS, Sione ring, BHEX pupil expander and different phaco choppers and glaucoma drainage devices. We decided to design and 3D print devices that aid in complicated cataract surgeries such as CTR, CTS, Sione ring, BHEX ring, glaucoma drainage devices for wet lab practice.
I used 3D computer aided design and 3D printing to design and print the glaucoma valves that we are talking about. So I used a free software called FreeCAD and drew the design of the valve which I had in mind. That was a foot plate. And once I had drawn the design and finalized it, I took it to 3D printing lab and used the resin 3D printer to print the model. There are two types of easily available 3D printers. One is the resin 3D printer and the other is the plastic 3D printer, which uses spools of plastic. Once the 3D printed foot plate was printed, I removed it from the mold, cleaned it with isopropyl alcohol and then kept it under UV light, and once that was done, the foot plate was ready to use. I used the tube from a Venflon to make the tube of the valve. Once the tube was cut, it was inserted into the hole of the foot plate, and so this is the foot plate and the valve mechanism, and that is the tube. If you look at the other side of the valve, there are 6 canals opening in 3 in each side. These allow the liquid to flow in from the tube.
We then fixed a bow tie in a plastic container and did a conjunctival peritomy to insert the valve. The foot plate of the valve is carefully inserted under the conjunctiva. Make sure that the conjunctival opening is big enough to accommodate the foot plate. The foot plate is then anchored to the sclera by suturing through the 4 holes using vicryl sutures. The tube is then measured and trimmed with the scissors. Once this is done, the next step would be to implant the tube into the anterior chamber. We have to make a track using a needle, partial thickness through the sclera into the anterior chamber in case of a phakic eye, and into pars plana in case of a pseudophakic or aphakic eye. Next step is to insert the tube into the tunnel so that it reaches the anterior chamber. Once the tube is inside, we have to make sure that it does not touch the endothelium. These are some of the other valves that we 3D printed compared to the first valve, which was actually quite big. The biggest one is the first GDT that we implanted in the surgical video. There is the small one with the tube, which is the latest design as of now, and there is also a medium sized one.
This is the top and bottom view of the first valve that we designed. We can see the flow of fluorescein dye through all the 6 channels in the valve conduit. This is a medium sized valve, top and bottom view. This is a design for the smallest and newest model that we had designed. This has a raised area on the top through which the tube is inserted, and it has multiple channels which channel the liquid into the bottom. The plate itself has multiple holes to allow fluid pass through into the subconjunctival space. The fluid flow is as seen in this video.
Here you can see the various CTR, CTS, Sione ring, BHEX pupil expander and glaucoma drainage devices made by 3D printing. We have published an article in the Kerala Journal of Ophthalmology called The Magic of Three-Dimensional Printing in Ophthalmology, where we have discussed the various uses of 3D printing in ophthalmology, including ophthalmic surgical instruments and devices. Several surgeons have used 3D printing for prototyping, including customized vitreoretinal forceps by Dr. David Chow, blepharoplasty instruments by Kotles, modified muscle hook by Dr. Danny Sow,
And the pupil expansion device Canabrava's ring by Dr. Sergio Canabrava from Brazil. Our very own Dr. Suven Bhattacharya has also used 3D printing to design the holder and storage case for the BHEX ring, pupil expander ring. There are also several other uses for 3D printing, including the smartphone based fundus cameras, including the foldable fundascope, Jondas foldable fundascope, smartphone based slit lamp imaging adapter that we have published along with Dr. Ahmed Ataya in the Kerala Journal of Ophthalmology. Even spectacles and lenses, including transparent lenses, devices for patients, including an eye drop helper and the glass dropper by Dr. Pavan, and eye drop helper by Dr. Shivagami. Surgical planning by using the 3D prints from the CT scans and MRI scans. Even optical coherence tomography 3D scans can be 3D printed. The 3D printed toys for the blind Fittle by LB Prasad Eye Institute is available. Bioprinting can be used for 3D printing cornea, that is also recently available. The 3D printed designs that we have created have been uploaded for free download on thingiverse.com and also in the National Institute of Health 3D website, that is the 3d.nih.gov of the USA. The Thingiverse website, you can see the various devices such as the BHEX pupil expander, the capsular tension ring, capsular tension segments, and so on. If you click one of these, so once you put it in 3D mode, you can rotate it and look at the design and then 3D print it. If you look at the NIH website, Orolog Aqueous Drainage Implant, the RD, and this is a 3D model which is also 3D printable in the resin mode. So these are the two websites where this has been uploaded and you can download them for free. After you download, what do? You can go to Google Maps and find a 3D printing shop near you. So for example, this is in Thrissur. You can look at the various reviews and photos posted. This is a resin based SLA stereolithography 3D printer, and these are all resin printed models. This is the filament based FDM printer. You can do FDM printing as well as resin printing here. So thank you. I hope this will help you to 3D print your designs.
Excellent, John, as always. But is there an intellectual property right issues with this?
So right now what I am doing is I am making designs and putting them up for open source design. So if you draw something and put it up as open source, anybody can use it with accreditation. I put it under the Creative Commons, right? You cannot copy some other existing design and use it commercially. So that is there.
This is for free.
This is for free. Mine are uploaded on the NIH 3D website and thingiverse.com. I have now put some MIGS devices also there. You can just go to the website, download it for free, 3D print it at any place available near you, or if you buy your own 3D printer, 14,000 rupees, you buy your own 3D printer, you can print it yourself. And these are all not biocompatible materials, so you can use it in the wet lab for practice. You can show it to patients and tell them this is what we are going to implant in your eye. So basically for teaching now.
That's what my next question was. Why not use a biocompatible material and get it for cheaper price, like bypass
Definitely
the
can be done,
whole
but
commerce of it?
there are lots of regulations on that.
That
So
can be
once you
patent
have
issues, no?
Yes, so patent issues are there, but that you can take care of it. The main issue is it's a much longer process and there are a lot of regulations. So not for medical use is my current approach. If you have a good enough design to do something different from what exists, you can do that. You can get a hold of a company which manufactures devices and tell them, I want this design done. They will take care of the regulatory problems.
The dimensions are changed. What you have designed.
So this one, you can scale it to any dimension. So I drew it. You can adjust the dimensions. I drew it in that shape, but the size you can adjust to any dimension. You can 3D print the CTR and the BHEX at that size, but when it comes to the CTS, it breaks apart with a regular 3D printer, which I had access to. With a much finer 3D printer, you can 3D print the smaller ones also.
More for us creating models and for teaching and wet lab.
Yes, sir. As of now, these models I have used in that method, but the same soft copies, if it is with the hands of somebody who has a very good 3D printer, they can use it for implant production as well. Mainly, this is for anybody who has ideas on a new design. You can practice out your design. You can plan out your designs and try it out. And once you make sure that that design works, you can contact a company and tell them to manufacture this in this design.
Yours is like a foundation.
Yes, ma'am.
Whatever your set is a foundation.
Yes,
That's what
ma'am.
I
Yes, ma'am.
understand.
Yes, ma'am.
Okay. Thank you.
Thanks, John. So, can we have Dr. Raisa Paul?